So what we've got here is a specific example of where the SN2 reaction has been used in drug design and synthesis. So this molecule here has been helpful in the treatment of AIDS, and what we needed to do for this particular drug is to have specific orientations of the group so that it could interact effectively and stop the virus from replicating. So the position that we're going to be looking at is this one here. So here, what they needed, crudely, was for this group here. You haven't come across it before. It's a new functional group called the azide functional group. Don't need to worry about that too much. It's just a new functional group that you'll learn more about another time. But they needed this to be in the down position. And so what they realised is if they could have a starter material with a leaving group in the up position, because we know that the SN2 reaction gives inversion of stereochemistry. It would be an appropriate reaction to use to try and make this with the correct orientation. Remember, as I've said before, it's important that we have correct orientations because different isomers can have different biological and therapeutic properties. So if they knew they needed this group in the down position, then they wanted to have the leaving group in the up position. So basically, don't worry about the rest of the molecule. That was important for the way it was going to interact with the virus. But what we can see here is our leaving group. And this here, lithium, you should know, is often found as the plus, as the positively charged species. So that means that the azide in this salt is going to be the negatively charged species. So effectively all that's happening here is our SN2 reaction. Our azide is going to attack this position at the same time as we lose our leaving group. We've not drawn it out, but it would go through the penta-coordinate transition state that we've seen before. And when we do the reaction, this is going to attack opposite to where the leaving group is, so we get inversion. So this bond here is a new bond which is formed, and it's inverted stereochemistry. And that was the key step in introducing that in the correct orientation. A whole series of different reactions were then required to convert this intermediate through to the material that was then used for the treatment of HIV. But it's a perfect example of where the SN2 reaction has been used in practice to make a drug which has had excellent effects in the clinic.